Hello friends. So in the today's question, so this is the figure and the question is, will the block move? If yes, then find the acceleration. If no, okay, it should be no, then find out the friction force on both the blocks and also find out the tension in the string. So it is consists of two blocks, 2 kg and 5 kg. The coefficient of friction is given 0.4 and 0.5 and the force is being applied is 25 Newton and 15 Newton. Okay, and this is string which is connecting both the blocks. So in this case, for the string and block, there is one important we can say consideration, okay, which means that role of the friction comes first, then comes the tension in the string. Tension in the string. So this is the important consideration which helps in solving the question. So in this case, let us call this as block 1. Okay, this is block 1 and this is a block 2. So for block 1, this is a 5 kg block and the coefficient of friction is 0.4 and there is a force of 25 Newton, and if possible then there will be tension T. Okay, then we will see whether it works or not. So there will be mg in the downward direction and that will be equal to 50, and there will be normal, let us call that n1 in the upward direction, whose value will be equal to 50 Newton. So we can say that, and if for block 1, if F1 max is the maximum coefficient of friction, okay, then we can say our F1 max will be equal to 0.4 into value of the normal, that is 50, and this will be coming as 20 Newton. And similarly for block 2, on block 2 we have F2 max as the maximum coefficient of friction, okay. From here you can say that our F2 max will be equal to coefficient of friction is 0.5. Let me draw the block 2, which is of 2 kg. So we have mg downward direction, that will be 20 Newton, a normal of N2, okay, and the applied force is 15 Newton, and if there is tension then it will be T. So it will be 0.5 into N2, which is nothing but about 20 Newton. So this will be into 20, and F2 max will be coming as 10 Newton. Next, we find out the external net force. Okay, find out the external net force. The external net force will be equal to 25 Newton minus 15 Newton. 25 minus 15, which will be coming as 10 Newton, and let us denote it as F ext. Now we also find out the maximum friction total. So we denote it as maximum total friction which is denoted as Fr max, and that will be equal to summation of F1 max plus F2 max, and we have our F1 max as 20 and plus 10, so we get Fr max is equal to 30 Newton. So from here we can make the comparison between the total external force, net external force, and the maximum total friction. So we can clearly see that our net external force is less than maximum total friction. Okay, and under this condition there will be no movement in the blocks. Okay. So under this condition you can say this implies that blocks will not move. Blocks 1 and 2 will not move. And simpler terms we can say that their acceleration of block 1 and block 2 will be equal to, let us given as A, which is equal to 0. Okay. Next is, now in these types of question, one of the important thing is that we have to consider the limiting value of the friction. Okay. We have to consider a limiting value of the friction. Okay. So let me write this, that this is very important consideration, that we have to consider a limiting value of friction in any one of the block. Any one of the block. So this is our first step. Second step, you can say that now this we have considered. Now if our assumption is correct, you see, if the assumption is correct, okay, assumption is correct, then we can solve the question further. Okay, if the assumption is correct, then the solution can be found out. And next is, if the consideration is not true, if the consideration is not true, then we shift our assumption to the next block. Then we shift our assumption, or rather, let me write assumption, or simply means consideration, to the next block. And this goes on in a circle. Okay. Next is, you can see, even now if this is not true, the third one, then again we go to next block, next block, next block. Okay, then we can say repeat the procedure if consideration fails. Now the important thing here is that it is basically hit and trial method. There is no hard and fast rule for it. Okay, this we can say is a hit and trial approach. But unfortunately or fortunately, there is no other way in solving this type of numerical. This is quite, it sometimes takes a little bit more time, but the results which we get is quite accurate. We are 100% sure that if assumption is not true, we shift to next block, and if there the assumption is not true, we shift to the next block. So assumption will be true in one of the block. Okay. So in this case, now we are going to make an assumption that, let us say that let us consider the limiting value to 5 kg. Okay, let us consider the limiting value to the 5 kg. Let us consider the limiting value of friction on 5 kg. That is block 1. So you can say from here that this implies that we have Fr1 max is equal to 20 Newton. Now we draw the individual free body diagram for this 5 kg block. So this is our 5 kg, and we have a force of 25 Newton, and if this is Fr1 max, which is 20 Newton, and we have a tension T, and we already said that acceleration A will be equal to 0. So under this condition we can easily find out what will be our value of T. Okay, so this is for written, so we can say T plus Fr1 max is equal to applied force, that is 25. So from here we can find out our T. T will be equal to 25 minus Fr max, that is 20, so which will be nothing but 5 Newton. Now we are going to verify our consideration by using second block, that is block number 2. So block number 2, we have a 2 kg. There is a tension T whose value is given as 5 Newton. Okay. And the force is being applied as 15 Newton, and we have here Fr2 whose value we are going to find out. So we can say that our T plus Fr2 is equal to 15, and from here we can find out our Fr2, which is equal to 15 minus T. T is 5 Newton. This will be coming as 10 Newton. Next, in order to evaluate, we make a comparison between Fr2 and maximum value of Fr2, and we already know maximum value of Fr2 max is 10 Newton. So from here we can say that our Fr2 is equal to Fr2 max. Okay, so it means the maximum value of friction, or we can say required value of friction, is equal to maximum value of friction. Okay. From here we can say required value of friction is equal to maximum value of friction. So this means that our assumption is true. Okay. This means our assumption or consideration or assumption is true. Therefore, we can say that our Fr1, that is the friction force at block number 1, will be our 20 Newton, and Fr2 will be our 10 Newton. Tension T will be our 5 Newton, and acceleration will be equal to 0. So this completes our first part, A part. Next we take B part. So in this case also the main question remains same, whether they will be traveling or not, and we can find out what will be the value of the tension and what will be the value of the accelerations. Here once again we can find out that there will be a force of 50 Newton rather, in the downward direction, and let us suppose there is normal N1 and whose value will equal 50. Okay, and here the friction we are assuming is Fr1, and here also it is 20 kg, and the normal is N2 whose value is 20. So we can find out the maximum value of, one thing more, the value of here is called as FR2. So we find out what will be our maximum value of FR1 and FR2. You can see that FR2 max, let me put 1 first, FR1 max will be equal to 0.4 into normal, that is 50. So we get this as 20 Newton, and we have FR2 max which is equal to 0.5 into 20, and this will be giving us 10 Newton. And once again we are going to find out the total external force, okay, or net external force, sorry. We find out net external force, we denote it by F external, and it is equal to 25 minus 18 Newton, which is coming as 7 Newton. Yeah. And we find out what will be our total frictional force. Okay, we can say, or we can say total friction force, which we denote as Fr max, which is equal to Fr1 max plus Fr2 max. So we can say that Fr max is equal to, we have 20 plus 10, that is equal to 30 Newton. Now making comparison between F external and F max, so we can clearly see that our Fr max is greater than F external. So from here you can see that blocks will not move, so therefore the acceleration will be equal to 0. Acceleration will be equal to 0. Okay. Next, once again we define the limiting value to one of the blocks, and then we calculate the condition. Okay, we say, let us consider the limiting value of friction on 5 kg. Okay, so let us draw the block for 5 kg. This is 5 kg. We have a force of 25 Newton, and we have this as limiting value. It means this will be now Fr1 max, and Fr1 max is our 20 Newton, and we can say that is tension T. Now we find out what could be our tension T. So we can say that T plus Fr1 max will be equal to 25, and value of T will be equal to 25 minus 20. So we have our T equal to 5 Newton. Now we are going to check whether our consideration is, or assumption is, true or not using the second block. Okay. So for block of 2 kg, so this is our 2 kg block. We are applying a force of 18 Newton, and there is a tension T, and we have, let us suppose here FR2 we already written, and we are going to find out its value. You can see that T plus FR2 will be equal to 18 Newton, and we know value of T is over 5 Newton. You can say that FR2 will be 18 minus 5, that is equal to 13 Newton. So total value of FR max, or sorry, FR2 max is 10 Newton. Okay, let me write here, FR2 max is only 10 Newton. So if you make comparison, this implies that our FR2 is less than FR2 max. Sorry, FR2 is greater than FR2 max. Okay, so from here we can say that limiting value cannot be on 5 kg. Okay, because the required value is 13 Newton, but available is only 10 Newton. Let me write it here. That is, required value of friction is 13 Newton, but the maximum available value is only 10 Newton. Therefore, you can say therefore the limiting value of friction cannot be on 5 kg block. Automatically we are going to shift it to our, that is 2 kg block. Okay, you can say that now, which implies that the limiting value of friction will be on 2 kg block. Okay. So we have F2 max, sorry, F2R max will be equal to, it was coming as FR2 is 10 Newton. So we draw the, you can say for block 2 kg, so here this is 2 kg, we have a tension T, and we have a force of 18, and in this direction we have FR2 max, and whose value is nothing but 10 Newton. Now we find out value of tension T, so we can say that T plus FR2 max is equal to applied force 18, and we have T will be equal to 18 minus 10, which is nothing equal to, T is coming as now 8 Newton. Now we are going to once again evaluate it for block number 5. Okay, so we can say that for block of 5 kg, so this is our block of 5 kg, it is being applied a force of 25, and we have a tension T of 8 Newton, and let us find out what will be value of FR1. So you can say that 8 plus FR1 will equal to 25, and FR1 will equal to 25 minus 8, which will be coming as 17. And the maximum value of FR1 max is 20 Newton. So you can clearly see the required value is less than the maximum value. Okay, you can see FR1 is less than FR1 max. So based on this, our assumption was true, and we can say that our FR1 is 17 Newton, FR2 is nothing but maximum value, that is 10 Newton, tension is our 8 Newton, and acceleration is 0. This is our B part. So we have C part. Okay. In this case, we have a block of 10 and 20, coefficient of friction is 0.5, 0.5, and forces are 80 and 110 Newton. Okay. You can say we have in the downward direction 20 Newton, and upward we have a normal N1 whose value will equal to 200, and let us say here the friction is given as FR1, and we have in downward direction here is 10 Newton, normal is N2 whose value will equal to 100, and the friction is given as FR2. So let us calculate the maximum value of respective friction values. Okay, so we can see that FR1 max will be equal to 0.5 into 200, and that will be coming as 100 Newton, and we have our FR2 max whose value will be coming as 0.5 multiplied by 100, and that will be coming as 50. And now same approach, we find out net external force. So we can see that net external force, that is denoted by F external, will be equal to 110 minus 80, and which will be coming as 30 Newton. And next we find out the total maximum frictional force. Okay, so we can say that maximum frictional force, let us say that is FR maximum, total maximum, FR max total, that will be equal to FR1 max plus FR2 max, and so we get this as FR max total will be equal to 100 plus 50, which will equal 150 Newton. So once again we make a comparison between F external and FR max total, and our F external is less than FR max, total. This means that acceleration, let us denote by a, will be 0. Next, we are going to once again say about the limiting value of the friction. Okay, so we say that let the limiting value be at 20 kg. Okay, let limiting value of friction be at 20 kg. So let us draw the 20 kg block. So 20 kg, we have a force of 80 Newton and there is a tension T, and we have here FR1 max, and whose value is 100 Newton. So we can find out our tension. We can say T plus FR1 max is equal to 80, and we can say our T will be equal to 80 minus, I think I made a mistake somewhere. One second. External force is 80 and FR max is 100. That's correct. Yeah, it's correct. 100 minus 80, which will be coming as 20 Newton. Now we are going to check whether our assumption is true or not. Okay, so we, for block of 10 kg, okay, so for the block of 10 kg, we find out the FR2, we are going to find out, and then we are going to solve it. So this is our block of 10 kg, tension T, and we have a force of 110, and let us suppose this is FR1. So we can say that T plus, this is FR2, sorry, T plus FR2 will equal to 110, or we can say FR2 will equal to 110 minus T. T was 20. Yeah, T was 20. So we get FR2 is equal to 90. But the maximum FR2 max is only 50 Newton. Okay. FR2 max is only 50 Newton. From here we can say the required value is higher as compared to the maximum value, the available value. So we can say that the required value, of friction, which is 90 Newton, is greater than maximum available value, which is 50 Newton. So our assumption was, consideration was wrong. So we can say that therefore limiting value cannot be on 20 kg. So we have change our hypothesis or assumption that let the limiting value of friction be on 10 kg. So let us draw the block of 10 kg now. This is 10 kg and we have a force of 110. There is tension T and this will be FR2 max, and whose value is FR2 max is 50 Newton. So we can find out our value of T. We can see that T plus FR2 max is equal to 110, or we can say T will be equal to 110 minus 50. So we get T will be equal to 60 Newton. Now we check this consideration using the second block, that is block number for block which was of 20 kg. Okay, so we have a 20 kg block, a force of 80 Newton, and we have a tension T, and we are going to find out our FR1. So we have T plus FR1 will be equal to 80, and acceleration is in the both the case 0. So we can say that our FR1 is equal to 80 minus 60. So we get FR1 is equal to 20 Newton, and the FR max is FR1 max is 100 Newton. Okay, it means required value FR1 is less than the maximum value. So basically this means our assumption is correct. Okay, so based on this we can clearly say that our FR1 will be our 20 Newton, FR2 will be equal to 50 Newton, and tension T is our 60 Newton, and acceleration is equal to 0. So there is another question with a slight modification. So now we have a wedge which is having angle of 37 degree and 53 degree, and the coefficient 2 blocks 5 kg and 5 kg, and the coefficient of friction is 0.5 in both, and the question being same whether they are going to move with what acceleration and with what will be the value of tension. Okay, so we can just divide. There will be a downward direction, we have a 50 Newton, and this can be divided into two components. This will be our 50 cos of 53. So this will be 50 cos of 53, which will be coming as 40 Newton, and this will be our 50 sine of 53, and which will be coming as 30, and this is a normal, so its value will be equal to 30. Similarly, we can write this one also. We have 50 in the downward direction, okay, and this component, this is the angle of 37, so we have, sorry, I think I made a mistake. Yeah, I made a mistake. This angle, so this will be cos and this will be sine, okay, because this angle will be 53. My mistake, sorry. And when we are in this direction, so this angle will be 37. Okay. From here we can say that this will be 50 cos of 37, which will be coming equal to as 40, and this will be 50 sine of 37, and which will be coming as 30, and we are going to have a normal, let us call this n1 and this is n2, which will be equal to 40, and there will be tension T as well as tension T. So as the movement is only in, there is no movement in the vertical direction, so what we can do, we can draw this figure in the horizontal way, okay, which means this is a simple surface, and now we have two blocks, 5 kg and 5 kg. They are connected by a string, and there is a force of 40 Newton in this direction, and there is force of 30 Newton, okay, and normal n1 is 30, and here we have n2 40. So let us call this as block 1, and let us call this as block 2, and here it is FR1 and here it is FR2, okay, because as the movement, there is no movement in the vertical direction, so we draw it as a horizontal object. So once again we find out value of FR1 max, which will be equal to 30 into coefficient of friction was 0.5 and 0.5, this will be 30 into 0.5, which will be coming as 15 Newton, and we have our FR2 max will be equal to 40 into 0.5, which will be coming as 20 Newton. Now once again we find out what will be the total external force, the net external force, sorry, okay, so we find out net external force, net external force, which will equal 40 minus 30 coming as 10 Newton, and the total maximum frictional force, okay, the total maximum friction, let us call this as FR max total, and it will be equal to FR1 max plus FR2 max. So from here we can say that FR max total will be equal to 15 plus 20 Newton, and that will be coming as 35 Newton. Once again, the net external force is less than the maximum frictional force. You can see, let us call this as F external. You can see that F external is less than F for max total, which clearly means that extension is equal to 0. Now if external is equal to 0, let us consider the limiting value on block number 1. Okay, consider limiting value on block 1. So we get FR1 max is equal to 15 Newton. So we draw the block diagram. This is our 5 kg, force of 40 Newton. This is our FR1 max, which is equal to 15, and we have tension T. You can see that T plus FR1 max is equal to 40, and from here we can find out value of T. T will be equal to 40 minus 15. So T we get as 25 Newton. And now we are going to use this for block number 2. Okay. You can see for block 2, we have 5 kg, and the force that is being applied is 30, tension T, and we have here FR2, whose value we are going to find out. You can see that T plus FR2 will be equal to 30, or you can say FR2 is equal to 30 minus 25, which will be coming as 5 Newton. And the maximum value of FR2 that is available, FR2 max is 20 Newton. So from here we can say that required value is less than the available value. From here we can say FR2 is less than FR2 max. It means the consideration is true. Okay, you can see that the consideration is true, which basically means we can find out that our FR1 will be equal to 15 Newton, FR2 will be coming as 5 Newton, tension T is our 25, and acceleration equal to 0. And we have one more question. Okay. And now this is a 3-block question, and in this case we are going to find out what will be our various same question. Find out the tension in case T1, T2, and acceleration and all those things. So once again this will be 30, and we have a normal of N1 which is equal to 30, and let us call this friction as FR1. Here we have 10, this is our N2, whose is N2, and let us call this as FR2, and here we also have 10. Okay, and we have N3, whose value is 10, and let us call this as FR3. 3. Okay, this is our block 1, block 2 and block 3. And we find out the maximum value of their FR1 max, FR2 max and FR3 max. We can say that FR1 max will be equal to 0.2 into 30, which will be coming as 6 Newton. We have our FR2 max, which is 0.3 into 10, which is equal to 3 Newton. And we have our FR3 max, whose is 0.1 into 10, which is giving us 1 Newton. Okay. So net external force is 50 Newton. There is only force in one direction. So we can say net external force, we call this as F external, is equal to 50 Newton. And we have total maximum friction. Total maximum friction force, which we call as FR max total, which will equal to 6 plus 3 plus 1. It is 10 Newton. So here we can clearly see that F external is equal to, is greater than rather maximum total. We can say F external is greater than FR max total. So therefore we can say there will be acceleration present. Okay. So it means blocks will accelerate. Blocks will accelerate with A. Blocks will accelerate with A, and therefore we can find out what will be the we find out that, let us combine these blocks into one. So this will be 3 plus 1 plus 1. So we have a net external force of 50, and we have FR max external, sorry, FR max total, which is coming as 10. So let us say this extra acceleration A towards the right. We can say that 50 minus 10 will be equal to 5 into A. So we get A will be equal to, this is 40 divided by 5. So we get our acceleration A as 8 meter per second square. Okay. So it means this will be acceleration of block A, sorry, block 1, block 2 as well block 3. Okay, so you can acceleration of block 1 will equal to 8 meter per second square. Acceleration of block 2 will be also 8 meter per second square, and acceleration of block 3 will be also 8 meter per second square. Okay, so we found out the acceleration. Okay, and let us say, and the important thing is that once the block starts to move, the limiting value of the friction will be the, or we can say maximum value of the friction will be their respective frictions. Okay, let me write it here. when blocks starts to move, then we have Fr1 will be equal to Fr1 max, and that value is 6 Newton. We have Fr2 which is equal to Fr2 max, and its value is equal to 3 Newton. And we have Fr3 whose value is equal to Fr3 max, and its value is 1 Newton. Let us find out one by one. Let us consider block 1. So for block 1, this is our 3 kg block. It is being force is applying 50. Now we have tension T, and we have Fr1 whose value is 6 Newton. So we can say T plus 6 will be equal to 50. Okay. Oh, sorry, I missed one thing. The acceleration is present here. My mistake. It is 8. Okay. So we can say that 50 minus T, rather it is T1. 50 minus T1 minus 6 is equal to 3 into 8, that is equal to 24. From here we can find out our T1. So T1 will be coming equal to as 20 Newton. Now let us consider for block 2. For block 2, this is block 2 whose weight is 1 kg, and here it will be force of 20 Newton acting, and this will be our T2, and we have here Fr2 whose value is 3, and acceleration here also is given as 8 meter per second square. So we can once again solve it. We can say 20 minus T2 minus 3 will be equal to 8 into 1, that is equal to 8, and we can find out T2. T2 will be coming as 9 Newton. Okay. So it means we found out the value of tension T1. Let me write it here. We have our Fr1 is equal to 6 Newton, Fr2 is 3 Newton, Fr3 is 1 Newton. We have tension T1 as 20 Newton, tension T2 as 9 Newton, and the acceleration. So acceleration of block 1 is 8 per second square. Acceleration of block 2 is also 8 meter per second square, and acceleration of block 3 is also 8 meter per second square. So this completes all the question. Thank you.